CDF12 has acted as a storage facility for Cuyahoga River sediment for years. These materials, when harvested properly, can have a beneficial use to provide a long-term sediment management solution. There are key conceptual steps to this sediment management approach: characterization, design, construction, and operation. The FothCDF12 joint venture team's optimized solution starts with CDF12 sediment characterization, water data collection, and surveying. During the characterization process, the findings will be analyzed to determine the composition of the sediment, the location of optimized well placement, and the mapping of material for strategic placement of legacy sediment. This process will determine the liquid levels, amount of chemical contamination, and grain size. Grain size will help define the mixture of coarse, fines, and suspended solids. By working towards recycling on the site and implementing a closed-loop process, we anticipate that a discharge permit will not be required. With characterization completed, design and construction will begin. During design and construction, dewatering wells will be installed at a location or locations determined during the site's characterization. These wells will be used to dewater areas to harvest identified materials for interior berm construction and/or beneficial uses, and if needed, to provide stability of berms. The installation of interior containment berms will facilitate development of cells in CDF12. This process of harvesting and dewatering will also aid in generating airspace necessary to receive future dredge sediment. In addition, roadways, weir structures, slurry water makeup system, and stormwater management systems will be constructed to manage the process flow. The team's aviation technical lead has communicated preliminarily and informally with the Central Flight Procedures Office of the FAA. We have initiated a preliminary evaluation of the potential opportunities and impacts of the current flight approaches relative to airspace clearance for construction and operation activities. We understand that addressing issues early on, with the end result in mind, is critical to achieving the port's goals. With construction complete, operation will begin. Dredge sediment will be brought in by barges and offloaded hydraulically. Recycled water from the clarifying or feed water pond will be mixed with dredge sediment to create a slurry. The recycled water used for the slurry mixture creates a closed-loop operation. The slurry will be pumped to a sluiceway to start the initial flow. As the sediment slurry flows down the sluiceway, coarser granular sediment will settle first. Fines will settle next in the dewatering drying cells. Lastly, suspended solids will be allowed to settle at the clarifying or feed water pond. The coarse granular sediment will be excavated from the sluiceway and stockpiled for beneficial use. The fines will be stored in the dewatering and drying cells until the cell is at or near capacity, and will then be excavated and stockpiled or stored pending characterization. Using an ongoing adaptive management approach, the decisions leading to the long-term use of this site can be modified as data is collected and as emerging opportunities support sustainable process improvements. An example of this adaptive management approach is shown by developing a designated area in CDF12 for legacy sediment storage and/or addressing the need for vertical expansion. Over the years, CDF12 will evolve into a process and reuse facility with the added ability to store legacy sediments. This new facility will assist with a variety of projects, not only for the port, but the City of Cleveland and neighboring areas, and will act as a sustainable resource for years to come.